So we get a restream here. I can't even move it. Uh, how come your new setup every time? This is actually, I mean, I'm in the new setup probably every couple of months because I'm just moving stuff, but I have a new setup now because I'm moving to Medellin, Colombia, leaving Manizales, Colombia. And so like I'm in like an Airbnb basically, and I also don't have my camera and I don't have my microphone, so like everything's just like lower quality basically. Yeah. I want to get a new microphone. I'm actually thinking about I'm gonna get one, but yeah, that's what's happening is that moving that stuff. Why moving? There's more stuff to do in Medellin. I think there's like better food. The food is better. It's a bigger city. Um, and my wife is like basically at a point where she can like leave the city because she's right like she was studying for architecture, but yeah, so that's where it is. And so I think the plan is gonna be where you lived before. I was in Manizales, Colombia. I'm gonna pull it up actually. Let me see here. How do I pull this thing up here? Let's see, we pull it up. Thanks for the follow, Stephen Ball. I don't even know how you knew I was streaming if you weren't following. Stephen Sagiball. As Midnight Simon says, Stephen Sagiball. Am I crazy? Okay, I was like, bro, am I crazy? Here we go. Oh, wait, also, I can't see chat, actually. Wait, hold on. Bobby was stalking you. Oh, nice. Nice. All right, yeah, so, where did I live before? So, I was living here in Manizales. It's like a city in the mountains. Pretty nice city. It's chill. It's chill. It's like a college town, but small. And then now I'm in Medellin. I'm in Medellin, Colombia, which is way bigger, and just better food here. I think there's more like just people. Like I mean, yeah, just more people too. And before I was in Manizales and in Colombia, I was living in Orlando, Florida. So when I worked at Citibank, I was like pandemic hit or whatever. I graduated, lived in Orlando, and then I like went over to go do live with my parents in DC, and then I went lived with my parents and like other in Florida, other parents, and then I moved to Orlando, and now I'm in Colombia basically, and probably living here I guess for a while. I don't know, but yeah, that's what I'm doing, JCAS, and so unfortunately the stream quality is just lower. Yeah, I need to fix it though because it's like it's killing a lot. Yeah, but hopefully I don't even know. Hopefully by next week, honestly, I'd be happy to be able to move. Honestly, but or maybe if not, then I'll just have to buy like a microphone. Maybe I don't know. I could also bring my microphone. I don't know, man. We'll see what happens. But anyways, I'm gonna go over this Leetcode list. It's been a while, so we're gonna just pop this thing open and go for it, man. San Diego Pog. Let's put this thing over here. Oh wait, I remember this one because I didn't do it. This is the one I didn't do. Construct a binary or tree from pre-order in order to reverse. Oh god, I do not want to do this. Because this is the one you have to measure the bounds. Like you have to go with three, and then you're like, the three is here, and like the bound is like there. Also, this thing is like terrible because I don't want the although it looks like the chat overlay for Restream is a bit better. It looks like embed chat, Restream, embed. I could embed it, and then I guess things would pop up here. But then I get two chats. Oh god, man. That's not fun. And then is the YouTube stream even like is YouTube 'Cause I don't see any YouTube comments, which is surprising, actually. Oh my god. Okay, I don't see any YouTube chat comments. That's cool. Okay, whatever. Yeah, I don't want to do this problem. I don't want to do that one. Adam Lip 13. What's up, man? What is up? I'm gonna cancel this one here. Wait, didn't I already? I did this one on stream too, actually. Okay, so I think we're done with trees then. I'm gonna check this one out maybe, and I don't even know if I want to do it, but Adam Lip 13. Checking out the Leetcode on some no video. No video. Okay, serialization is a process of converting a data structure into a sequence of bits that can be stored in memory buffer. Design an algorithm that can serialize and deserialize a binary tree. There is no restriction on how it should work. You can just need to ensure. So this one, you just need to have null things in it, I think. So like you just encode it as a string, something like we can have like some tree here, and then we can just say like one, what's the left child? Like what's the right child or whatever. It could be anything, right? Like, and then we need to say like, okay, for two, like what's like the left child and the right child. And in this case, we can say like null null, for example, and then just go again, I think for three, and probably just go through it through pre-order traversal through everything. And then when you read it, you'll do a pre-order traversal. So you'll say, in this case, I think it should be like 2 is the left child, 3 is the right child. And then we jump into 2, and then we're like null null or something. I don't know if that's bad. I mean, you could even say dot dot if you want, and then jump 3, and then say like 4 5. Feels weird. Oh, like I never did this one. Yeah, you gotta do it, man. I gotta do that list. Gotta do all of them, all the problems on it. Going to do the first contest tomorrow. Nice. Jaguar Yoru, are you still applying to jobs? No, I'm full on into startup land. I love trees. I just hate this one. Yeah. I don't think I like tree problems that much, actually. Definitely prefer graphs. That's definitely I'm better at graphs. And I wish I was good at trees, but I mean, I honestly am good at trees, but just like probably not compared to, I guess, world-class people. But I think I'm good at it. Okay, so I think where this one we just put this one, and then here, but then I wouldn't have no idea which one I'm talking about because then I skip to these two and I don't even know. So are you now working at a startup? No, I'm building my own startup. But a tree is a graph. Yeah, the tree problems and graph problems are very different. Like this one is I think I tried breaking it down, but like it's like for trees it's a lot of recursion. And it's also by breadth first search, but like the breadth first search is usually just level order traversal. It's not like a Dijkstra's or anything. So you're just going this level, this level, this level, and but a lot of like just recursion. It feels like for trees, and it's not even. It's like how do you get, and then also how do you get the common ancestor, binary search trees, and like I guess problems like these where you have to serialize. Which actually this one's probably a little bit different, but I don't think it's. I don't know. Before jump in DP. Before jump in, DP should be understand. Graph, tree, backtracking first, right? Look at this, yeah. Look at the Neetcode thing. Trees and then backtracking. That's what he has it as. I think he has it that because trees are more visual and backtracking is like harder to visualize. Yeah. Yeah. Okay. How do I do this? Let's see here. I need to just see left, right, and then bang, left, right, and then And then go next, go next. And then 3. But 3 I would be saying is a child of the empty. Oh God. I can encode it like this. I mean, I might as well maybe try serializing it just to like maybe get code out. But like, so it would look something like def DFS, like node, and then like if node, DFS, like node.left, DFS node.right. Just like super basic, whatever. We could even do this pre-order though, but like serialized like that. And then we just say like root or serialized dot append node.value. And then if it's not there, then we just append like an empty thing of it. So it could be like a dot. And then at the end, we just return it as a string. Like that. Now the problem though just comes, how do you decode this? So I know the values, I know like, that's why I think I'm liking go start and then just left, right. And then go next. And then left, right, which is null. And then go next. Create a 3. And then DFS again. Fuad. What is up? Fuad. Oh, watching the process solving a harder problem. I'm surprised, people. But that said, it's probably good motivation. It's a Friday night, 10 p.m. in the United States on the East Coast. And we're here just solving problems. Here just solving problems. Let's see here. Okay, let's see here. So 1, 2, 3, and this serialize isn't even doing this format that I even created, but 1, 2, 3. Also, we can 1, 2, 3, 2, blank, blank, 3. Just started graphs and topological sorts. Yeah, I'm hoping that I can finish this pretty soon. Hoping I finish this list pretty soon. But not if I'm getting problems like these. But I guess not. I don't know. Actually, I mean, honestly, the easies are easy to blaze through, and tries would be like I could finish that so easily because that's something I'm actually good at. Backtracking, I think I'm good at. Graphs, I think I know, and then DP, I think I know all of these for sure. And then 2D DP, but I think some of the stuff's like, yeah, the tree stuff is like kind of difficult though. I actually haven't. I don't know, man. I got a question for you. How long do you usually spend stuck on a problem before looking at the solution? I'm spending 20 minutes on these just because I don't want to spend that much time. But it really doesn't matter, honestly. I mean, Solaris is like one of the best lead coders I've seen, and he spends days looking at problems, trying to upsolve them. But for interviews, in an interview setting, you're timed. So you're only going to get 30 minutes. So like I think it's fair to say like if you can't get in 30 minutes, like just give up. But but the thing about short timers is you kind of kill your ability to problem solve because that's what LeetCode is like you're kind of problem solving. Like even right now, like I don't know how to solve this, but like I'm still trying to like figure out how to solve it basically. And that is an act as like a skill basically that you kind of build and you get stronger at it the more you do it. But anyways, all I say is just do 30 minutes. I'm only doing 20 minutes for these. Yo, can you explain your experience interviewing with Meta? Jaguar Yoru. I can explain it if you. Was the one I signed like an NDA for it, so I don't want to publicly talk about it. But you join the school group and just DM me. I'll tell you about it. Yeah. Also, shoot, actually, let me. Oh. Let me see here. I'm gonna send it just in case you are curious. But yeah. Oh, but like TLDR, I did well on everything. I made like a couple mistakes, and those couple mistakes were enough for them to not move forward with me. But I think I got to hiring committee, so it was good enough to get through that, but not enough to pass hiring committee. I can say that, and that's not violating anything. I prepped with studying Leetcode and doing mock interviews. Okay. Oh my God. Let's see. How are we doing this? How are we doing this? This can't be that hard. The problem is I don't like the 2, 3 because I'm still like double adding. I don't like double adding. There's like got to be some other structure I could do. Maybe I play around with other structures. What other structures could we do? Like we could say one left child is like a 2, right child is like a 3, and then build it that way. So then we start, build the node, dig down left side because it's not null, and then attach the value to it, attach the value to it, and left goes with left goes with that returned value, but then the next step we go in. How do we know what the next step is? How would I know what the next value should be when I decide to step? Because I have the pointer here, but it shouldn't be. If I had two lists, that would actually kind of be based, right? I just have it in pre-order traversal because then I kind of know what it's going to be. And I can just go through and I'm just like, oh, well, you're not null, so let's go jump. And then we're like, okay, well, let's clear this, and then just kind of keep going through. Yeah. I think that works actually. Why are you adding an extra two? Yeah, I think this works actually. I think you can have two sets. One set that is like the actual pre-order series of it, and then you can have another one that's like the serialized version, and then the serialized version is just gonna say like one, and then it'll have like I guess like 2, 3, and actually shoot, I don't know how that actually works. Why am I adding an extra two? Because I want to keep track of the children of the two. Why not do a pre and in order? You probably could do pre-order and in order, maybe. I don't know. I don't know anything about that. Like the other problem, you probably could. But I want to check is does it even have children? Is basically what the one and the two when the or adding two twice is for. Because I would still want to keep track of it, and then maybe have a pre-order traversal one. Pre-order traversal dot and no dot value. Let's do this and then say like I guess no dot left dot value. I guess. I don't know. I think this is like fine. I think this probably works. Maybe. I think this works. It's serialized pre-order traversal, and then just like I guess keep it serialized and also doubled. It's probably not necessary, but I think this would work. And then what we do is this is like super over complicated. What we do is then we add a dot to it. and then go here and then add a dot. And this will create this kind of structure of like of like 1, 2, like 2, 3 or whatever, and then we'll also keep like 1, 2, 3, 4, 5 for like the in order traversal. And then now we can just go through in order through these and say like, oh, what's left and right, and then go through. That's it. I also need to join these. So what we could do is split them based off like a slash, I guess. Maybe the two parts. Pre-order, traversal. And then when we have the data, we can say like the serialized is equal to data dot split off a slash, and then do pre-order traversal. And actually, I don't think this works. I think you literally need to like this. Cool. Yeah, so this will get us both when we do a split here, and then now it's just like, I guess, going through. With pre-order, and then let me call this serialized. I might be able to finish this in 20 minutes, maybe. So what we can do is do I guess as our pointer, and then say if serialized at I, or better yet, if I less than or greater than equals to length of serialized and 0 or something, I don't know. And also return true, return false. There, I need to do that. And then we can do is go through the serialized, and then again just 1, and then like check the left, check the right, which are always going to be 2 steps. The Theo, hey you, thanks for the follow. We're just doing some Leetcode for the contest tomorrow. Okay, so yeah, so it would always be number and then 2 steps will tell me the tree or the left child and right child. So we'll always say like left child is equal to serialized, and then like node is equal to serialized at I is I plus 1, and then we'll have right child is I plus 2, and then we just need to check it doesn't even exist, and then also create the node of it. So that'll be fun. So let's create the node and then create the left and right child. So then it'll be like DFS left child, but DFS I plus 2. Oh no. Let's see here. If left child not equal to a dot. No, that doesn't make sense though. Because I would need to have this kind of current is I or something, and then do like current plus equals like 2 or something. Something like that. Okay, new left node, new right node, and then we'll have like tree node, like new node is equal to tree node with the value of like the integer node, and we'll say new node dot left is equal to new left node, and then new node dot right is new right node. and then we'll just return the new node. And then we'll just return DFS at 0. Okay. Now that said, I never even used this pre-order traversal thing, so that's not good. I've only got like 1 minute left on this. Oh my god. So one thing I need to do is like new left node equals new right node is equal to none. So he was pointed to none. But this two-step thing, so it's like one, okay, does it have a child? If it does, then skip 2 and then start processing it. Does one have a child? Okay, then skip 2. But that, I don't think that actually accomplishes anything. I think that's failed, but whatever. Whatever. So they, yeah. I need to print out the nodes, but it's not even. And object has no attribute value. Tree node? Should be tree node for this. None. Yeah, just empty. Okay, whatever. Use a filler for when it doesn't have a child. He already did that. That's what the dots are for. I missed something up here. So this one, like, I had the same idea, right? Pre-order, like, this is, like, pretty much my idea. Flat binary tree, have a deck, pop left. This code is, like, so much simpler. This code is so much simpler. DFSQ, value, pop left. I don't think this is needed. This thing, I don't think that's needed really. But pop left. And then you check, is it null? How did I miss that? Node equals tree node, node left. DFSQ, DFSQ, no, return node, return none. This is like more or less how I'm encoding it. More or less. Except I don't know why I had this idea of doing this thing, this pre-order thing. And like double adding it, they shouldn't be double added, but just 1, 2, and 3. Let's run it. Return the pre-order traversal of them. So it would be 1, 2, but this time it would be like dot dot 3, 4, dot dot 5, dot dot. So it has to be the actual pre-order. I wonder if I could do this doing post order or something that would have helped me. Dang, I messed you up. No, you didn't mess me up. No, you didn't mess me up. No. I should have did the pre-order like this. I should have just read it as pre-order and then just read it, I think. So then we say 1 and just build it back. It might have been easier if I saw it as post-order for me getting this. Or something. Like just do straight up pure post-order and then just like bang bang. Or what, I guess post-order is this way. Like bang bang. No, I don't even know, man. I don't know. Probably not. Probably not, but Yeah, it's a fast solution though, for sure. Just split it and then just pop left and just start building it back up every time. And then just have it return the nodes. So they all keep track. I love doing pre-order, making a string like 4 in to 5 on D serial, they split. Yeah. Yeah. This is how I solved it in the past, but yeah. Okay, well that's another failure for this one. These are tough. Neetcode ain't pulling punches, man. Neetcode ain't pulling punches. All right, let's go into a good problem. Let's do some tries. One problem that I cannot screw up. Cannot. Impossible. Impossible, impossible. I'm gonna try a prefix tree. A pronounced as try is a tree data structure used to visually store and retrieve keys. You just want to insert, be able to search, return true if the word is in it, and then if it starts with something, if it has a word that starts with it, then return true or false. So pretty nice. This is a pretty like easy try problem. If you haven't done this type of problem before, which you probably have if you're watching the stream, honestly. But just to reiterate what a try is that like as you store words, so you can have something that's like a, or let's say like cat actually, because I like it's easier to say. You can say CAT, and then you can say like yes, this is a word, and you can mark it as like true basically. So like instead of having a really long dictionary and not knowing like if words inside or whatever, you can know in like just a faster time complexity. And if you need to search if a word for a specific word, you can search for that word in login time. So the structure can allows you to, and so you can say, okay, well this is false, it's not a word. This one's false, it's not a word. And then if somebody wants to say, oh, CA is a word now, well then we can just set this to true and ignore that stuff. So this is kind of the general try structure that's out here. The prefix tree, yeah. And my general template for tries is just like you do class try node, and then you do like the def init or whatever self and self dot let's see self dot what is it children. You can have a children and then just have like a default dictionary, and that'll just initialize the try nodes. And then you can also have something that just stores like content about it. So sometimes you want to store like the number of words. Sometimes you want to store if it is a word. In this problem, we just want to store is it a word. So we'll just initialize that to false. Here we also want to just store the root. So we can define that as our initial try node. And then in terms for inserting, we want to have recurrence, so self.root, and then do for character in word, and then do current is equal to current at ch. Now, this is the cool beauty of doing the default dictionary way, because you can just like instantiate the new word if it doesn't exist, and then you'll go through all the way and then just say like current dot is word equals true. So that's actually that's how I insert. And for searching, we'll just go through again. So current is equal to self.root or ch in word if oops, my bad, I actually messed this up. It's dot child dot children dot children. If let's go try tree ch if ch not in like the dictionary. And honestly, I don't know why I did word that out that way, but like you say current.children.get ch none. So if it's is none, then just return false, because it's obviously not here. And if we do reach the end, we need to return if it's a word. And I also need to advance it if it isn't. So then we go here, and then we just advance it. Yeah. And for starting it with, I wish I was setting the timer here. For starting with the prefix, now we just need to see like, does it have children actually? So exact same code, return false if we can never actually reach it, but now we're just going to return like the length of its children. So return like the length of current.children not equal to 0. And I'm gonna just just pure run this thing, man. I think this code is good. I have confidence in myself that I did not typo anything. We can look over it again. The current.children. Yeah, I like it. I like it. I like it. Let's run it. Does it work? Oh, I did word, not prefix. Rip. All right, let's run it. Run it. No, I messed it up. Messed up. All right, let's see here. What did we do wrong? What kind of startup are you working on right now? B2B, B2C. Business to consumer. Yeah, business to consumer. Honestly, right now I've got like two, but I think I need to focus down on one so that I can actually like grow it maximally without divided time. The first one is like AI startups, AI, AI automation for lawyers. So I built out a couple AI solutions for lawyers. Yeah. Um, where are we at? Hmm. Okay. What did I do wrong? Insert search starts with. Okay, starts with is obviously true for this one because it has an A. When I go through here, I go through the children, but I actually never loop. No, we do loop. We loop A. Or maybe or is word. Possibly. I don't know. Possibly. Oh, I don't know if I want to submit again though. Feel kind of bad. Is word. I think like, that's it. A is a word. So we jump into A and we're like, okay. Yeah, okay. That was the mistake. I did a typo here and then I didn't do or is word. I wonder what I did in the past. I don't think I did the same thing. This is a super useful template though. Yeah, here it is. If current is word, return true. Yeah, so I did have it. This time I just put in the or statement though, but yeah, a little bit of a mistake. This is a really, I mean, yeah, again, it's just super useful template, honestly. Like, I like this is like the cleanest way I think that I've seen to do this problem, or use like kind of any kind of try, and it's like super fast to write out. Default dict is clean. Yeah, I like just like put it just default dict, and then now you can just like go through it, and it's pretty fast. You can type it out pretty fast. I think everything makes sense to me on it. So we'll go here. Design and add search words data structure. So we want to return true. We want to add the word and then return true if there is a string in there's any string in the data structure that matches it. Word may contain dot, where dot can be matched with any character. So this is a bit different because now we can actually have dots and match with any character. So that means that we need to go through all possibilities whenever we see a dot. So that's like a recursion type problem. And for that, I'm gonna full on just copy and paste this thing over here because I don't want to deal with that. I think word dictionary, the names are a bit different. Names are a bit different. Self dot. Self dot root is equal to try node. And then obviously we know how to add words. It's the same code as this. Exact same code as here. Bro, please switch. Oh wait, I do all of my coding interviews in Java. LOL. I've had people recommend me to use Python. No, I think it's fine. If you want to use Java, it's fine. Especially, I think there's like a learning curve for Python. Although Python's pretty nice for interviews because you can do it very fast. But like if you're gonna interview, I mean, they're gonna grade you on how well you know the language. Like that's like one of the criteria. So you don't want to like get caught with your pants down. Switched from Java 2 years ago. Fingers feel the difference, yeah. But yeah, I switched from C++. Granted, I wasn't even, I think I solved like 10 Leetcode problems in C++, but at that time. Is this last minute interview prep? Is this last minute prep for the interview? Nope, this is not. This is just me kind of vibing out, man. Vibing out and trying to do this. Apparently you guys like these videos. So, yeah, I just make these basically for that reason. But I can do Java without thinking. XD, I have to practice on Python. Yeah, yeah, I would just use Java, especially if you're already good with it. Like, there's no reason to switch, so, in my opinion. Like, I mean, the reason would be if you want to code faster in interviews, but I mean, you don't need to, because even if you do in the Java interviews, like I think it'll help in the Java job interviews, especially, because they love testing your knowledge. Okay, let's restart this thing. So continue word, and then we just say it is a word. That's lovely. And then when we search the word, we do want to use a similar thing here, but we do want to go through, but then that said if ch is equal to a dot, well, then I want to add every character. I actually want to go through every character. Now the problem here is that we need a stack to go through every character in that child. So like current dot children dot keys or whatever. We just want to go through all of those and then add them into a group. I'm thinking normally I do this DFS, I think, but I think I can just do this with a stack, right? Like this, possibly, or no? Hmm. Nah, nah. That's too complicated. We'll just do DFS. Count the position of I if DFS I. This is Y, by the way. Thomas C, did you have an onsite coming up? Yeah, I had meta onsite, which I did do, and think I did well in it, but got to hiring committee, but they rejected there, to my knowledge. So that is yeah, that's what happened there. Now for the yeah, this is also why like I think the tries and backtracking. I mean, it's kind of weird, but like this try problem relies on backtracking. I mean, also the trees one too, but it's kind of interesting. But like if we reach the end, then we know it's good. If we ever reach the end, and if not, we're just gonna keep kind of bouncing through. So we're gonna say like ch is equal to word at I, and we'll just check this. And then we're just like for I don't know val and vals or whatever, just like DFS I plus one, I guess. We do want to pass in the node too, so to be current dot children at ch and like else it's current equals there, and then like DFS I plus one current, I guess. Current dot children at ch actually. It's probably better, yeah. I kind of wrote this weird though, this vowels thing, and it honestly doesn't even need to be this way. You could just do this. Like that. And then this would just be val, right? Or no? Yeah, hold on. Oh my god, wait, what? No, it's a dot, so it has to be val. Okay. Yeah, just a little DFS through it, DFS through, and I want to try to clear this one perfect again too, no submission. I think it's really good too. No submit's really good for interviews, I feel like, because in interviews they want you to debug it yourself. So root current, yeah, like that, and then here we just go through just I, and then if not, or if we actually ever hit something that's true, then let's just actually just run it, man. If it's true, we're done. And if it's true, then just return true. If it's not, then just return false. And then we need to return DFS at 0 here. And I need to pass in the actual value here for the node. So be current, and I think this is fine. Except for this, actually, that's not gonna fail. It's like that. So current, pass. This is wrong completely. But yeah. Cool. Now let's just run it perfect. Hopefully, hopefully, hopefully. No typos, no typos. And something wrong. Hmm. If it's a dot, go through all of the keys and then go through them. If it's weird, then you put a word, return true. Add word, add word, add word, search word. So we word dictionary, add word, add word, add word. Oh, but we're saying pad is in here though. How does that make sense? How does that make sense? There's not even a dot in it. There's literally no dot. What? What did I do wrong? Word at I. Bad, dad, mad, pad. Add. We're only adding 3, but then we search, but then add. Oh boy, these late Leetcode sessions. All right. Also, have you heard anything about X Twitter interviews? Have a bunch coming up. I have not heard anything about them, but my guess is it's Leetcode based, if I were gonna guess. And I think I think I still have Leetcode Premium, although I need to cancel it because I don't think I'm gonna be using it anymore. But honestly, I don't even think Twitter is hiring, so I don't see anything a whole lot. My guess is it's Leetcode, if I were to guess. Yeah. So like this kind of stuff, these kind of problems. If that helps. Pepper on. Oh, I didn't know about that list. Thank you so much. Leetcode has like problems. I think. I mean, I'm not sure how accurate it is or anything. I literally don't know anyone interviewing at X. I didn't even know they were hiring. I mean, actually, I think they were hiring, but like for senior, maybe. I don't know. Working under Elon. Okay, what did I do wrong? Go through all the keys, obviously. And we just pass in those. I could go through all the values too and just pass them in directly, but I think it's okay. But it should just return false if it never hits. Oh, maybe I need to check if it's actually a word. Maybe. Maybe, I don't know. If current dot is, or like return current dot is word or something. Maybe I need to do that. Yeah, it works now. Kind of hard to see that though. Kind of hard to see that. My solution's also super slow. See what I do in December. Also wrote a really slow solution. Okay. So I don't know. The try. Maybe there's a non-try solution. No? You go through everything in the word. Yeah, I don't know about that. Whatever. I guess whatever. I don't know how much. Maybe this is faster too. When searching, if the max length of the word search is greater than the max length, return false. Maybe that's like the thing. The optimization. Anyways, all right, we're gonna do this one, this one. I've done word search 2 before also. This was actually probably one of the first like hard Leetcode problems I'd done, I think. But I actually recently did this one too, I think, October 15th. So I'm not gonna bother doing it again, honestly. Although it's pretty cool. Like you just mixing kind of like finding islands with a try and then passing in the node and where you're at so far. But pretty cool. I think I like it. I like it. I like it. I'm gonna skip it though. So we're gonna close that one out. And then next time I'm gonna go over backtracking. So we're gonna try to solve all of these, see how fast it takes me, but a lot faster to solve tries because I'm actually good at these, and I think I'm pretty good at the backtracking too, so I can get through those. And then graphs, I'm also pretty confident in everything here actually, except for the math. I think I can solve. Trees are tough. Trees are tough. Cool. All right. Well, that has been Neetcode's Leetcode list for trees. Hopefully you guys kind of like this. There's a Leetcode contest tomorrow, by the way. If you guys didn't know, you probably should know from watching this. But there is a contest in 10 hours. Let's see what this is. Minimum array end. I want to see what this thing is. You have two integers n and x. You have to construct an array of positive integers, nums of size n, where for every 0 I less than n minus 1, n plus 1 is greater than nums at I, and the result of the bandwise is x. Oh god, more bit manipulation. All right, I don't want to do this one either. I'll think about it though for a little bit. I'll consider thinking about it. I don't know if I'll solve it though. N and x construction array where for every value the next number is going to be greater than the previous number, and the result of the bitwise and is all have the same bits. That's actually not bad, right? Ooh, but return the minimum possible value. So not any one, but the minimum one. Okay. Well, one, I think the minimum possible value needs to be x, right? Because you have to have the same bits. You have to have the same bits. And I'm pooped from the interview, so I'm taking the weekend off of Leetcode. Dang, nice. I mean, nice you're getting interviews too. And going through them. Yeah. Take a nice break. Let's see. I think the biggest number always has to be x because that's always going to have the biggest ones. And you could probably work backwards from x. Maybe pull like just one bit off of it. Peel one bit off of it. No, but the and operation between everything needs to. So these aren't ors. And we'll be reducing it. And we'll reduce as we go along. So it's actually opposite. The minimum number in the array needs to be this one, at least. Now, you can add stuff, slowly increment maybe. No, that's confusing though. Slowly increment is confusing. Like you start with 4, but then you add something in, and you could reduce it really to 4 or any number. It's a tough problem actually. But that's I mean I've also only spent like 2 minutes on it, so you should spend more time, but I really don't want to do bit manipulation stuff. Let's see what the zero track says for this problem. It is a very hard problem. 2000 rated. 2000 rated. All right, I'm gonna head out. I'll see you guys later. Just a quick hour streaming session. I think what's this? What does this mean? Oh, you can knock people and ask them to collaborate. That's interesting. That's pretty cool. So we're just like encouraging that. Okay, I'm gonna raid Simon, I guess. And although I think probably a lot of you guys are watching, but if you guys don't know who Simon is, he's a Google software engineer, and he is like way better at LeetCode than me. And uh, you check him out. He just goes over stuff. Now I think he's just trying to update his website. It's pretty cool. So I'm going to read him. Also, for anyone who is in, or I guess anyone who has not heard, anyone who has not heard, I've got a DSA community. If you guys want help with anything, interviews or whatever, you can join that, and I'll help you. I'll try to help you. So peace. I'll see you guys later. I'm gonna raid Simon right now, and I'm gonna sleep. And I might as well toss this thing in here too. If you guys want to jump over to his stream, you can. And all right, peace. See you guys. Thanks for watching. I'll see you another day. Most likely tomorrow. I'm gonna be streaming like every day, or I'm trying to stream every day, at least for this month. But we'll see how that goes. But yeah. What's my okay, never mind. Hey yo, no condom Chris. What is up? Contest tomorrow. Heck yeah. Might do one contest for sure, I think, but I don't know about both. One thing I feel I kind of want to keep my where I popped off last contest. I kind of want to keep my placement, man. I'm top 3% now. I don't want to ruin it. I don't want to ruin it. But yeah, 320. Solved 3 questions in 10 minutes, man. 3 questions in 10 minutes. I don't want to ruin my thing though. I told you about it actually when this happened, and you were like, you should do Q4. Now you're close to Guardian. Oh yeah, I don't believe that. I don't believe I'm close to Guardian at all. Simon's not even Guardian, and he's better than me. All right, I gotta dip. I gotta dip, Chris. I will see you later. And see you guys later. You peaked last contest. Heck yeah, Chesraw. You peaked on last contest I saw. Yeah, thanks, Buffer. Thanks. Dang it, the raid expired. Now I gotta do it again. /raid midnight_Simon. Oh my god, /raid midnight_Simon. Cool. All right. Yeah, no, if I had to guess, I would probably say it's gonna take me another 4 months or 5 months of just like hard studying to get to Guardian or Leetcode Guardian, like top 1%. But because I gotta do DP, I gotta do segment trees and all that, and that's gonna be another thing to learn. But maybe one day, I don't know. I think it should be happening soon, I think. I mean, I just gotta focus more on the business thing so I can start having like an income, and then I can start playing around with like exploring this. But yeah. All right, peace. Thanks for watching, guys, and I'll see you later again. If you want to join community, go ahead and join the link for the school group. I'll try to help you with your interviews. If not, it's cool, but yep.
And I gotta change up my query a little bit. Man, the real Raymond Jones rated again. 2 times, double rated. Welcome again, man. How you doing?
Okay, nice. All right, well, I
That's the
rated him
rates
twice.
today.
All right.